In this video, we will look at dividing a decimal number by a whole number using base 10 grids. The focus of this standard is using models, drawings, and strategies based on place value to compute problems. Let's take a look at how we can use base 10 grids to divide 5 and 12 hundredths by 4. Before I solve, I want to think about a reasonable quotient. And one thing that we could think about here is that if this were 5 divided by 5, and I feel that I could use that for the estimate since 4 is close to 5, and 5 and 12 hundredths is also close to 5. If this were 5 divided by 5, the quotient would be 1. So this lets us know that our answer will be close to 1. We could also reason, though, that since we are dividing by a number that is smaller than 5, our quotient would actually be a little bit more than 1. So to begin to solve, the first thing we want to do is represent the number that's going to be divided, which is the 5 and 12 hundredths. So we'll shade 5 and 12 hundredths on the grid. Remember that each flat here, or each large square, represents one whole. So far we have 3 holes shaded in. Now 4, 5, and then we'll get our 12 hundredths, and that can be represented with 1/10 and then 2 hundredths. So now what we need to do is think about, well, I need to split this 5 and 12 hundredths into 4 equal groups. So the first thing we could look at is, well, do we have enough holes to give each of the 4 groups one whole? And since we have 5 holes, I know that we do in fact have enough to give each group one whole. So I'm going to go ahead and represent that now by just saying, well, this hole will go to group 1, group 2, group 3, and group 4. Again, since we're splitting the 5 and 12 hundredths into 4 equal groups. I see now that I don't have enough holes to give each group another whole. This lets me know that our quotient is going to be one whole and then some more, since we still have some more to divide. So when we look at what's left, we see that we have one whole and 12 hundredths. Let's take a look at how many tenths that means we have altogether. We have 10 tenths in this whole, and then one more tenth in this final section here where our 12 hundredths is represented. That means we have 11 tenths, and we could think, well, if we have 11 tenths and we need to split that into 4 equal groups, how many tenths would we be able to give each group? So I'm thinking that we would be able to possibly give each group 2 tenths. So I'm going to go ahead and start with that. And if we find that we need to give them more tenths, we could do that also. So I'm going to circle 2 tenths and say that's for group 1. 2 tenths, that's for group 2. And I was thinking each group could get 2 tenths because I know that 4 times 2 tenths would be 8 tenths, and 8 tenths is pretty close to the 11 tenths that we had. So let's see, we'll circle another group of 2 tenths. That would be for group 3. Another group of 2 tenths, and that would be for group 4. So when we look at what we have left, we have 1, 2, 3 tenths and 2 hundredths. So we know that that in fact is not enough to give each group another tenth. And so now we can look at this, the remaining amount, as how many hundredths do we have altogether. So we know that in each tenth we have 10 hundredths. So we have 10, 20, 30, 31, 32. We have 32 hundredths left. At this point, some students may use their number sense and think, well, 32 divided by 4 is 8. So we should be able to give each of the 4 groups 8 hundredths. Some students may not be able to reason like that at this point, which is fine, and may find it easier to just number the hundredths that are left, 1, 2, 3, 4, to represent the 4 groups, and just repeat doing that. Some students may think, well, let's start by giving each group 5 hundredths because we know that we have enough to do that, and then go on from there. Any one of those approaches is perfectly fine. I'm going to go ahead and model giving each group 5 hundredths and going on from there. So if I give each group 5 hundredths, so 1, 2, 3, 4, 5, it could be for group 1, 5 hundredths here for group 2, 5 hundredths for group 3, and 5 hundredths for group 4. And I see that I still have some remaining over here. I have 12 hundredths left. I could think, well, if I have 12 hundredths left and I divide that into 4 equal groups, that would be 3 hundredths in each group. Or if that was something that wasn't coming to mind, you could also just go and number like we had said before. So we could say group 1, 2, 3, 4, group 1, 2, 3, 4, group 1, 2, 3, 4. And now all of the hundredths have been equally divided as well. So now we just need to look back and see, well, how much is in each of these 4 equal groups? I see that each group has 1 whole. I know that each group got 2 tenths. And I can see that each group first got 5 hundredths. And then, let's see, I'm going to use another color to show this. So each group got 5 hundredths. Like I'm looking at group 1 here, 5 hundredths. And then they also got another one here. So 6, 7, 8. And the same thing is true for groups 2, 3, and 4. They got 5 hundredths there, and then 3 more additional hundredths in that last section. So that would let me know that each group got 8 hundredths in addition to those 2 tenths and that 1 whole. And so that would show us that the quotient is 1 and 28 hundredths. So 5 and 12 hundredths divided by 4 is 1 and 28 hundredths. And that answer is reasonable based on our estimate. We thought our answer would be close to 1 whole, but a little bit more than that, and that is what we got. And so this is how we can divide a decimal by a whole number using base 10 grids.